Hi, this is question number 4 from the Texas STAAR 2013 geometry exam. The question says, in the diagram below, the angle of depression from P to Q is 45 degrees. And then it has a picture. I guess somebody's looking down a cliff at an angle of depression of 45 degrees, and it shows that they're looking at a point 32 feet away from the cliff. And then it asks, which of the following is closest to the distance between P and Q? Okay, I think I understand what's going on here. I know what an angle of depression is. That's when you're looking down. And I see that a right triangle is formed. And if I know that angle of depression is 45 degrees, I know that this has to be a horizontal, and I'm going to assume the ground is horizontal. So this angle here has to be 45 degrees, because this angle and this angle, the two green angles, are alternate interior angles, and these lines are parallel. So now I've got a right triangle. It's got a 45 degree angle. I know one side is 32 feet. Oh, that must be a 45, 45, 90 right triangle, and I know that that is a special right triangle. So if I've forgotten how to use special right triangles, I can look at the formula sheet in the exam. Okay, here's the formula sheet. You can see the two types of special right triangles, 30, 60, 90, and 45, 45, 90. And I've got a 45, 45, 90. And what this tells me is that the two legs are going to be the same, and the hypotenuse is going to be the square root of 2 multiplied by the length of the leg. So let me go back to my problem. I've got my leg length is 32. So to find the length of the hypotenuse here, all I got to do is take 32 and multiply it by the square root of 2. And I get, let me pause and grab my calculator, 45.25. That's what I get. So that looks like answer choice F. Oh, I forgot about this down here. Okay, did I understand the problem? Yeah, I think I understood it pretty well. I knew that I was dealing with a 45, 45, 90 triangle, and I know what an angle of depression is when you're looking down from the horizontal. My plan was to use what I knew about special right triangles. Could have used trigonometry, could have used the Pythagorean theorem. There's other ways to do it. I executed that plan, and how am I going to check my answer? Well, Pythagorean theorem might be a good way to check it. I know both legs of the triangle are going to be 32, so I can check it by seeing if 32 squared plus 32 squared is about equal to 45.3 squared. Remember, 45.3 is rounded, so these aren't going to be exactly equal, but they should be pretty close. So that's a good way to check my answer. Okay, there you go. That's number 4. I hope that helps.